Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 6-2 in the SavvasRealize Algebra 1 textbook. Today's video is covering graphing exponential functions, which is interesting because their problem itself doesn't actually ask you to graph, but okay, let's do it. So it says that there's a network administrator who's using the function f of x equals 5 to the x power to model the number of computers that a virus spreads to after X hours. It says if there's 1,000 computers on the network, about how many hours will it take for the virus to spread to the entire network? So what I'm actually going to do is I'm going to take you to Desmos. And let's take a look at this function. So f of x equals 5 to the x. Alright, so there is our exponential graph. You can see it's asymptotic to the x-axis. So our question's asking us about 1,000 computers on the network. Alright, so the x-axis is the amount of hours and the y-axis is the number of computers. So what I'm doing is I'm going to the top, there's like a wrench, and I'm going to work on kind of changing some of my layouts here. So let's see, I want y to be 1,000. And I'm going to take it out a notch so I can see just a little bit more. Okay, so there is the graph zoomed to where the y-axis goes up to my 1,000. And so you could see that right here is where that 1,000's at. And so my x value at that single point looks like it's about like 4.3. Alright, I mean, I'm just rounding to the nearest tenth. So that means that it would take 4.3 hours to to get there. And so what I'm doing is I'm trying to encourage this thing to label. Maybe I could just, there we go. To label that point so you could see it when I go to take a snipping on it. So I use these videos for my class, so bear with me while I screenshot that for my Jamboard. Alright, so you could see that right there it would take about 4.3 hours. And again, we live in a polite society, so answer with a full response here, okay? So it would take approximately 4.3 hours for the virus to spread to the entire network. Now, kind of interesting about this, you know how it's talking about a computer virus, but an actual virus, like a cold, such as COVID-19, spreads in the same type of pattern as a computer virus. So their names being similar, well, there it is. Now part B on this, it's asking about 50,000 computers. Our process is going to be the same, but I need to take my y-axis now and call it 50,000. I'm going to zoom out just a little bit more so I could see it. So 50,000 is about right here, right? A little higher. So it looks like it's about 6.7 hours. So I'm going to update our point so that it shows it on there. So for problems like this, where it's a graphing question, all you have to do is plop that bad boy into Desmos and check out the ordered pair. Alright, and again, that was about 6.7 hours. Now again, this is an approximation, right? It wasn't exactly 6.7. I rounded it. Okay, it's not exact. Um, in order to get an exact answer, you guys need something called a logarithm, which you guys don't learn till Algebra 2. Okay, so this approximation kind of has to be good enough. But there we have it. That is looking at exponential functions on a graph. Until next time.